All right, so now on to part two of our strong base weak acid titration. And remember the math, I don't have it on this form, but the math is just like those strong we did before we left. All right, so we already know, we already know it's halfway to equivalence. All right, so acid-wise, we have 40 milliliters, 0.10 molar of acid, which gives us 0.004 moles or 4 millimoles. Base, we have 20 milliliters of 0.10 molar milliliters. That's a milliliter. All right, to give us 0.002 moles of hydroxide or 2 millimoles of OH minus. Your net ionic equation will be CH3COOH, acetic acid, hydroxide, going to, well, where's the proton donor? Acetic acid, so we're going to make acetate. And we're going to make water. Now, here's the difference. This is a conjugate base. So it's going to be different. It undergoes hydrolysis, doesn't it? So it's going to be different. This is why our pH calculations are different in the strong weak. All right, so ice table again. All right, we start with 0.004 moles of our acetic acid. We start with 0.002 moles of our base. And of course, we start with nothing here. Now, change. Minus 0.002 minus 0.002 plus 0.002. And those are all moles, right? So, base, OH minus, is the limiting reactant. It's gone. We end up with 0.002 moles of acetic acid. And we end up with 0.002 moles or 2 millimoles of conjugate base. Now, they're in the same container. If they're in the same container, they're going to have the same concentration. In this case, what's our volume here? What's our volume? Well, we have 40 milliliters of acid and 20 milliliters of base. So that's a combined total of 60 milliliters. All right, 60 milliliters. Well, what is the new concentration? New concentration for these, let's just keep this color, 0.002 divided by 0.060, because those are moles, those are liters. That gives us 0.033. All right, but they're in the same container. They're going to have the same concentration. Now, the new thing, Henderson, Hasselbalch. All right, so when we have a concentration of acid and concentration of its conjugate base, not from the initial, but actually present in solution like we do now. All right, acid and its conjugate base, we can use this equation where the pH is equal to pKa plus the log concentration of the base over the concentration of the acid. So in this case, the pH, the pKa is just a negative log of Ka, right? Plus the log of the base, which would be CH3COO minus the acid CH3COOH, acetate and acetic acid. Alright, so the pH is negative log 1.8 times 10 to negative 5 plus the log of 0.033 over 0.033. Well, some of you guys are already seeing that that's the log of 1. So, well, that's the log of 1. And so, log of 1 is 0. So the pH, this is the big part, halfway, pH equals the pKa for strong, weak. In this case, the pH equals 4.74. So anytime we've added base to our titration. So as soon as we add base all the way to the equivalence point, we can use this Henderson-Hasselbalch equation.